lecture number 5. In this, we are going to learn the definition, operational definition, and measurement. So let us have a brief recap what we have studied in the last class. In the last class, we learnt about a term that is total quality management. What it is? Total quality management was originally coined in 1985. So we are taking care into all the aspects right from scratch till the end so that the whole quality can be controlled. So in the last class, we also saw that how these companies, what is the success behind this, all the multinational companies such as HP, IBM and Motorola, they have got their own objectives and how they are adopting the standards to reach this total quality management. So in the last class, we also saw that customer is the final arbiter, that is the key theme of the IBM's company. And these strategy comprises of many initiatives such as defect elimination, cycle time reduction, customer and business partner satisfaction, adherence to the Barbridge assessment discipline. In the last class, we also saw this diagram of the 4 important things, that is customer focus, process improvement, human side quality, and the various models or frameworks that are being used as the key element in the total quality management. Today, we shall focus on the measurement theory. I think if you recall the old classes, you might be knowing that we have got 2 theories. One is the popular theory, another is the professional theory. When we talk about the popular theory, we don't know. We tell that we are not particular about measurement. We tell that it cannot be measured. But when we come to the professional theory, professional view, measurement is an important part, isn't it? So scientifically, if we want to tell this quality is better than that, then we should have some scale, we should have this measurement. So that is, finally we are coming to some point of the outcome. So the parameters, there should be some parameters which should be defined and which should be measured, isn't it? So it is undisputed that measurement is crucial to the progress of all sciences, isn't it? So it is undisputed that measurement is crucial to the progress of all sciences. Means scientific progress is made through observations and generalizations based on data and measurements. The derivation of these theories as a result and in turn confirmation or refutation of theories via hypothesis testing based on further empirical data. Means we must measure it, isn't it? So for that measurement, we have 2 things. First thing, we will have this hypothesis. We will come to next. We will see in the next slides what is the hypothesis, what are the empirical data, isn't it? Through these means, we are going to measure various parameters. As an example, consider the preposition: the more rigorously the front end of the software development process is executed, the better quality at the back end, isn't it? So a very general preposition, we all know that how much effort we put, isn't it? How much effort we put on the more rigorously the front end of the software development process is executed, the better quality at the back end. Means if front end is rigorously made, obviously it is affecting to the back end. So to confirm or refute this proposition, we first need to define the key concept, isn't it? For example, we define the software development process and distinguish the process steps and activities of the front end from those of the back end. So we are making here 2 distinctions, isn't it? 2 categories. One is the front end and another is the back end. We will see this. So we need to have, whether it is a front end or whether it is a back end, first let us define all the various phases. The various phases of our development process are: it starts from design reviews and inspection, the code inspection, debug and development test, integration of components and modules to form the product, formal machine testing, and early customer programs. So 1, 2, 3, 4, 5, 6, 7, isn't it? So these are the 7 phases of the development phase. It starts from the designing, taking the reviews and coding and inspecting the code and debugging and finally integrating, and we are taking the early customer program. These are the various phases. So what is that integration? Here we are telling that integration in the sixth step, isn't it? What is that integration? So integration is the development phase during which various parts and components are integrated to form one complete software product. If you work in software company, so you will come to know that one project has been divided into so many modules. Different people will be working on different modules. Finally, the project manager or whoso is leading it, so he will integrate all the different modules. That is nothing but the integration, isn't it? It is a very important step. Until unless we integrate, we cannot call it as a product itself, isn't it? So integration is the development phase during which various parts and components are integrated to form one complete software product. Usually, after integration, the product is under formal change control. Specifically, after integration, every change of the software must have a specific reason, isn't it? So, example, to fix a bug undercover during testing and must be documented and tracked. Therefore, we may want to use the integration as the cutoff point, isn't it? Means all the software, small softwares, all the small modules we are integrating, then we are going to test. The design, the coding, debugging and integration phases are classified as the front end of the development process, and the formal machine testing and early customer trials constitute the back end. So we are having the two different ends of the software product. One is the front end, another is the back end. The designing, the coding, debugging, integration phases are classified as the front end of the development process, whereas the formal machine testing and early customer trials constitute to be back end. So see, we were talking about some measurement, isn't it? So how we are going to measure it? Another indicator of good reviews, isn't it? So we have to measure. So there should be some scale, isn't it? That's why in the earlier, just in I have shown the scale, isn't it? There should be some means so that we can measure. We are measuring the parameters. Same here. Another indicator of good reviews and inspection could be scoring of each inspection by the inspectors at the end of inspection, isn't it? Based on a set of criteria. We may want to operationally use a 5-point Likert scale. This is Likert scale, isn't it? It is having five points scale to denote the degree of effectiveness. Example, see how we are going. We are scaling it in such a way that if the parameter gets 5 points, it is very effective. If it gets 4 points, it is just effective. If it gets 3, somewhat effective. If it is 2, not effective. If it is 1, it is a very poor inspection. It's unsatisfactory. So one operational definition of rigorous implement may be inspection coverage expressed in terms of the percentage of estimated line of code, means LOC, or the function points that are actually inspected. So just in order to summarize what it is, the indicator. The indicator, we are taking the reviews. And what is the indicator? The indicator is taking care of two things. One is the LOC, line of codes, or of the function points in the code, isn't it? So these two things, they are inspected. They are inspected across 5 different scales. It starts from 5 best to till it ends to the 1. So this is very simple to understand. So we have got various indicators. That indicators, they are taking into account of LOC or FP, functional points. In addition to design reviews, code implementation and code inspection, development testing is a part of our definition of the front end development, isn't it? So at the front end, what we are doing, the code inspection, all these we are doing the front end. We also need to operationally define rigorous execution of this test. I have marked this rigorous execution, isn't it? Means we have to execute in such a way, so many times we have to find the bugs. So two indicators that could be used are the percent coverage in terms of instruction execution as measured by some test coverage measurement tools, and the defect rate expressed in terms of number of defects removed per 1,000 line of code. We are calling it as a KLOC. K means that 1,000 K. That LOC, line of code, or per function unit. So what is it? It is rigorous execution. How we are accomplishing it? We are taking two things into account. We are taking two indicators into account. One is the instruction executed, means how many instructions are executed. So we have got the measurement tools, means we have got the testing measurement tools from which we can know that how many executions are executed, and how much the defect rate is. The defect rate is expressed in terms of number of defect removed per 1,000 line of code. If the defect rate is less, we can tell that it is a good one. We can give the if the defect rate is 0, then we can call it as a very much effective. If it has got so many defects, then we will give it a 1 rating, so that in the scale it is a poor one. Likewise, we need to operationally define the quality at the back end. See, here we are talking about the front end, isn't it? So code implementation, design, and all that. When at the same time we have to we have to take care about the back end also, because the software comprises of two different ends, front end and back end. Likewise, we need to operationally define the quality at the back end and decide which measurement indicators to use. For the sake of simplicity, let us use defects found per KLOC or defects per function point during formal machine testing as the indicator of the backend quality. In order to assure the backend quality, we are using this defects found per KLOC. Same thing what we did for the front end. So this is the parameter which is telling us at what level the backend is, at what quality level the backend is. Now we will see the three testable hypotheses. Let me clear you what is this hypothesis. Hypothesis is nothing but an idea that is suggested as the possible explanation for something but has not yet been found to be true or correct. Means it is just a theory which is not yet proved. Means we are assuming something a nazriyati muamma we call it as a, that is just it is a theory which has not yet been proved. So three things are there. For software project, higher the percentage of the designs and code that are inspected, lower the defect rate at the later phase of formal machine testing. What it tells? Three things it is telling. Higher the percentage of design and code that are inspected, how much we inspect more, lower the defect rate at the later phase of the formal machine testing. It is very obvious to understand, simple logic, isn't it? The more we inspect at the design code, the less there will be defect rate. What is the second hypothesis tell? The more effective the design reviews and code inspection as code by the inspection team, the lower the defect rate at the later phase of formal machine testing. The more effective the design review and code inspection as code by the inspection team, the lower defect rate at the later phase of formal machine testing. Same thing here also. The more we inspect the code, the inspection team is taking much more care of the code at the level of code inspection. Obviously, there will be less defect rate at the formal machine testing. The third hypothesis tell the more thorough the development testing in terms of test coverage before integration, the lower defect rate at the formal machine testing phase. The more thorough means complete development testing if we do in terms of test coverage before integration. Before integration itself, we are testing it in a thoroughly. Definitely, there will be the defect rate will be very much lower. So all these three hypotheses, what it tells, the more we inspect at some level, definitely we are getting the less defect rate. Here also the defect rate, here also the defect rate. The defect rate is getting to be reduced the more we inspect. So these three are the three testable hypotheses. So the hypothesis thus can be tested empirically. What does it mean? Empirically, empirical based on experiments and practical experiences, isn't it? Just now we told this is hypothesis. Hypothesis is just a theory, isn't it? What is this empirical? Means tajrubati nazriya. Means what we do? We conduct the experiment and find out whether it is correct or not. So here it is clearly shown that there is abstraction level, isn't it? So there is some abstraction level. For this abstraction level, we are having this theory, preposition, isn't it? So we have got the concept, definition. These are all at the abstract world. Means theoretical world, we have all this, isn't it? When we come to this empirical world, this hypothesis, data analysis, the building blocks of theory and concepts and definition. In a theoretical definition, a concept is defined in terms of other concept. Here, the building blocks of theory are concept, the building block of theory, isn't it? The building block of theory are concepts and definition. What we talk about theory? When we talk about the theory, it is nothing but the theoretical things and concept and definitions. In theoretical definition, a concept is defined in terms of other concepts that are already well understood, isn't it? So importance of it tells, this demonstrates the importance of measurement and data. Measurement and data really drive the progress of science and engineering. Without empirical verification by data and measurement, theories and prepositions just remain abstract, isn't it? See, unless we practically do some experiment and we get some data, so everything it remains abstract only, means it is a theory only. The example also illustrates that from theory to testable hypothesis and likewise the concepts to measurement, there are several steps with level of abstraction, isn't it? At the level of the abstraction, there are so many things, but simply a theory consists of one or more prepositional statements that describe the relationship among concepts for usually expressed in terms of cause and effect. In theory, we can tell that this is the cause, this is the effect, isn't it? From each proposition, one or more empirical hypotheses can be derived. So the concepts are then formally formed and operationalized. The operationalization process produces metrics and indicators, isn't it? When we come to the real world, definitely the operationalization process, it produces some metrics and it produces some indicators. So from which we can know that at what level the quality is. We can measure the quality of the software. A hierarchy from theory to hypothesis, isn't it? This is theory to hypothesis, and from concept to measurement are indicated in this diagram. The building blocks of theory and concepts are definition. In a theoretical definition, concept is defined in terms of other concept, and it is already it is very much clearly understood. In the deductive logic system, certain concepts would be taken as undefined, they are primitives. All other concepts would be defined in terms of primitive concept, isn't it? So this diagram, it tells that there is a abstract world and there is an empirical world. In this abstract world, we have got so many theory, we have so many concepts. When we come to the empirical world, these hypotheses will not remain as a hypothesis because we are doing the operational, we are getting the empirical analysis, means actually we are doing the data analysis. Finally, we are getting the parameters in terms of the real world measurement. So operational definition in contrast are definition that spell out of the metrics and procedure to be used to obtain data. See, finally we are coming to this operational definition. It is in the empirical world, means it is in the practical world. It is some measurement we are doing. So an operational definition of body weight could indicate how the weight of person is to be measured, the instrument to be used, and measurement unit to be recorded the result. Just simple example they have given of the body weight. Suppose the body weight is the parameter which also what has to be done, how a weight of the person is to be measured, then what instrument we have to use, what should be the unit of measurement to record the result. Same way, an operational definition of a software product defect rate, I have marked in yellow because it is important term. The operational definition of software product defect rate would indicate the formula for defect rate, the defect rate to be measured, the denominator, the line of code function, how to measure and so forth. Means we will come to some formula so that we can find out the defect rate, isn't it? How much defect rate per the line of code, KLOC, 1000 line of code, how much defects have been occurred in so and so code. So in this way, we are scaling it, we are measuring it. We are setting two parameters. One parameter is the defect rate. At the numerator we are writing, and in the denominator we are adding the LOC or function point. In this way we are going to measure it. So finally we are coming to some scale. We are telling that this is of this scale, means suppose from 1 to 5, 5 is excellent, 1 is poor. In this way we are coming to some point, we are telling that this is good, this is excellent, this is bad.